Okay, we're going live. We live. Listen up. It's your boy. It's your boy CNC Daddy Joey Bizzle. We out here crashing machines and crushing dreams. I got my coffee in the foul language mug. All the language on the mug is foul because it's birds, and also foul. How are we doing today? How are we doing? We're making a reaction wheel. Probably the next CNC stream ends up on the BPS channel, but I want to do a few of them on the Joe Barnard channel just so it's like, you know, chill and cool and fun. How do I get the guy here? I'm gonna snooze all of my notifications. Remind me in an hour. All right, so we're doing two things today, two parts. There's, and once again, I don't have drawings or things to show you because I didn't prepare. There's a reaction wheel. It's for a 74mm airframe. That's what Scout F is gonna use. We're doing the reaction wheel first. The reaction wheel is gonna get heat set onto a motor, which is somewhere, presumably, and I did a test of this yesterday where I can show you some of the parts I made. Oh my goodness. All right, hold on. This will be worth it. It's a really cool looking part. Alright, well, I can't, oh, it's right here. It's been chilling in the water for a hot minute. So I made some parts yesterday because we're going to heat set the reaction wheel onto the motor. We're using a tiny little DC motor like this. There are probably better motors that we could use for the reaction wheel, but I don't want to use them because I already have these motors and I know that they work well. Or they work well enough. So what I did yesterday is I created a couple of different parts where, if you can see this, I've got different hole diameters here, and so this is in millimeters. I knew the diameter of the shaft of the motor, and I did like a little bit of math on like how much we needed to heat up the part to get effective expansion so that we could get the shaft through. And what I found is like it's like a tenth, like a 100th of a millimeter is what I have to undersize it by. I don't think it's very reliable. But for a part like the reaction wheel, which is not going to see insane torques from one of these little DC motors, it's probably fine, even if it were just like a regular old press fit. And that's, you know, that's the plan. We've got our first piece of stock material is set up here. Oh! Shouts out, by the way. Someone commented on the last CNC stream, they commented after the fact that my coolant wasn't set up correct, and they were right. So in the last stream, we had I had been using this bad boy right here, Extreme Cut 251C, cutting and grinding fluid, and I had just been pouring it straight into the coolant reservoir, which is not how you're supposed to do it. I'm still learning a lot of this stuff. It's evident, but you're actually supposed to dilute it. So I've diluted what I think is about the proper amount with water and cutting fluid. So the mister should work a lot better. It's a fog buster. It's just gonna like mist things. It should work better now. We'll find out, right? What else? Yeah, so I got the tolerance pieces. We're gonna make the reaction wheel first, and then we're gonna make the housing that houses the reaction wheel. That's gonna be a little bit more tricky. The housing is gonna come out of this block of stock. We're gonna get rid of a lot of this material. And then the reaction wheel is out of 1/2" extrusion that I cut down about to the right size. We've got it mounted here with these, are they called toe clamps? Is that what that is? I'm like pretty sure these are called toe clamps. Someone can vibe check me in the chat. We don't vibe check on Fridays, but it's Thursday, so it's fine. Is this for Phineas? No, it's not. This is for Scout F. So the Scout F is the millionth iteration of Scout that I've been trying to build so that we can actually land one of these rockets. In a couple of days, I've got a video on throttle control coming out on the BPS channel. We're just waiting for like sponsor approval and a couple of other things. But the throttle control is going to let us dial in the landing a lot better, and so we're making some really nice parts to go on Scout F. Yeah. Okay, yeah, Garfield says 1 gallon should mix to make about 20 gallons. Right. I know that now, and thankfully I bought a bunch of funnels, so I was able to recover all of the coolant that was in the reservoir and put it back into the you know, like the gallon that they gave me. But lesson learned. And it's just going to take a little while for all of that coolant to sort of cycle through the lines. Oh, it's Perry. What it doing? Yeah, Perry, we out here making a reaction wheel. It's gonna look really nice when it's done too. So why don't we get started? This stock is already set up. I'm gonna check the tightness on the clamps, and then we're gonna get started. I've got the tool paths ready for both things. So we should be able to spend most of our time here actually making chips and taking cuts, instead of me in the other room like yelling at Fusion 360. I also need to buy a proper wrench for this. And then our work offsets should be fine for this. I think I set them last night, but you know who I don't trust? Myself. So we're gonna do it again. Any idea of when it will fly? Well, those who are in the patron know that I've been working on a different thing for a long time, and that different thing, which we will not say the name of, just got pushed back to April now, which is great. I'm definitely not losing my mind about it. But that means we have a lot of March open to do whatever. So I am gonna like try and kind of push hard to see how much we can get done in March. So like maybe soon? We'll see. Anyone want to bet he still doesn't have a proper air gun? Brian, I will not take that bet. I don't have a proper air gun. Have you seen the last El Shang video? Let's look. I think I've seen all of his stuff unless he uploaded in like the last few days. I saw, the meteor shower of man-made. I don't know what that means. I didn't see that one, but I've seen most of his rocket project. Stuff is really cool. Okay, why don't we... Oh, Perry, I got a fourth axis in the cart on the Tormach website. I can't quite bring myself to pull the trigger yet because it's like $1 billion. I think I should probably like make a few more parts, make sure it's fine, but the fourth axis is very attractive. All right. Toe clamps seem to just clamp the piece from the side, not from the top. Okay, so these are not toe clamps. These are clamps. Let's do this. So the first thing that we're gonna do is probe the part so that we can get our work offsets. I'm also going to re-reference the machine, and I warmed it up earlier today. I don't think you need to warm it up like before every single time you run, unless you're doing, unless you are doing it like unless you're using the machine like once every month or so. But anyway, that's all to say. I warmed it up and oiled it, so it should be ready to go. I'd love to see more baking with Sila. Maybe we'll do one this weekend. On Saturday, if anyone lives in California, by the way, on Saturday I'm going to Rock out in Lucerne to help my buddy get his level 3. And we might try to... no promises. We might try to fly Phineas then. It'd be cool to try it if it's ready. But anyway, I've got a friend in town, so maybe we'll do a little baking show. All right, we're referenced. So now we can set some work offsets. We've got tool. We need to go to tool 99. In the future, I should get a screen of Path Pilot up on here too. That would be helpful, I think. All right, so we're gonna probe the Z in the center of the piece, or center-ish. Okay, and we'll probe off of here. Here we go, so this is gonna set our X. Makes me so nervous to use this thing, man. I envision some connection error in the cable where it just keeps plunging into the material and ruins the probe. It's a nerve-wracking experience. Setting our X, Y, and Z is not that critical for this part because we're just cutting it out of the piece itself. The Z is the most important, but even that is not crazy critical. Ah! Damn it, okay. I hit a limit switch, and it really doesn't like that. Even though I referenced the machine, so like that doesn't seem... Anyway, I'm good at my job, and no one say anything. Gonna have to re-reference all of the axes. Okay, just gonna put a blank tool in there. Oh boy! Yeah, so the fourth axis is really good. Like, I forget that I do circular parts, and that's really what it's for. Like, we have to drill holes in the housing for the reaction wheel. We're gonna have to make some holes for it, and that would be a lot easier with the fourth axis. But what I'm gonna do is just like make a jig for the drill press and call it a day. How's the party? Says Jared. Jared, the party's bumping, dude. It's absolutely bumping. Also, does anyone want to see what I got in the mail? Sort of hashtag Jared. Check out this new hat I got. I kind of like it. Jared, what do you think? I know you're out here seeing all of the orders that I've been placing for new merch. I kind of like the pink BPS hat. I feel like maybe I got this other pink hat that has it's a donut cat on it, and I really like that. So I got one with BPS on it, and I kind of think it's nice. Yeah, it's like a salmon. It's a little salmon hat. All right, we're re-referenced. Let's get a rough idea of our zeros. So like this should be pretty close to 0 on both, and it definitely is, so we're good. Yeah, that's the corner. So, file, Scout F, reaction wheel 1, load G code. Let's take a look at what we're making. Let me get the camera here. So this is what we're making today. I'll leave it zoomed in so you can see. We've got, the toolpath looks a little whack, but we've got, is this right? Yeah, I think it's a 1/4 inch. Okay, the toolpath looks whack, but there are 3 spars. Wow, this does look really weird. I don't know, it looked fine in the chem. There are 3 spars that hold the wheel on. All of the mass is concentrated around the outside of it. And actually, with this, we can probably turn off the display. There we go. That's a little nicer. Yeah, there's like 3 spars there. Why is it not well aligned? I think that's just the adaptive. Anyway, this is what we're making. It's like 60-something millimeters in diameter. It's not quite all the way the diameter of the airframe, because what I wanted to do, I haven't settled on what if we want fins at the top of Scout F. I'm not convinced that we need them for this, but in case we do, and we need to run a servo cable or a GPS cable or whatever past the reaction wheel, that was a hard thing that I had trouble with on Scout E, where we had to like route cables along the outside of the vehicle. I'd rather keep them inside, so the wheel is a little shrunk in diameter, and then we have a guard, like the housing is a guard around the cables, so that cables don't jam in the wheel. Oh, are we talking about white balance? Looks pink to me. Oh yeah, no, it is. So on the webcam, this is pink. Like that looks pretty accurate on the webcam. The difference in the hats is subtle. The BPS hat is more pink. It'd be cool to do it like a more salmon version of this. The pink is a little intense on this one. I don't know, I just like the way they look. And they're better for the desert too, because black hats are gonna heat up your head in the desert. All right. So, we should get to work here. We got parts to make. When can we expect Joey B and William Osmond collab? I kind of want... if he still has the, I don't know if he still has the X-ray machine set up. I think it'd be cool to try and X-ray one of the Ava things. I don't know that it would make a good video, but I don't know. I only met him once, and he plays a lot of Magic the Gathering. He seems cool though. All right. Are we all ready to make some parts here? We're using 3 tools on this. It's a 1/4 inch end mill, a 1/16 inch end mill, and a 90-degree spot drill, which we're going to use for chamfering. The 1/16 inch end mill is going to be tricky. Do we not have an 1/8? Yeah, I guess we don't have an 1/8 inch end mill. We'll see how that goes for me. All right. Oh, that's not right. 1/16. 1/4 inch. Okay. One thing I want to do before we get started is get coolant in the lines. So, oh! I hit another limit switch. All right. Need to re-reference. I see you also stocked up on some normal shirts. I did, Jared. So I don't know what happened. We use. I'll peeling back the curtains on the big fancy BPS merch. We use Printful to do the fulfillment for orders. We've had like pretty good luck with them, I think. And so I have all of these old BPS shirts. Like I have these old white ones and black ones that they look fine, but Printful like super duper upgraded in the last year and a half or so, and so my shirts are like all out of date. They're this older fabric, and I just ordered a bunch of new BPS shirts because like the fabric that they are using now is a lot nicer than the one that they were before. Anyway, oh, and then I bought some for my parents. They wanted shirts too. Okay, let's get some coolant in here. Wow, it turns on right away. Look at that. That's amazing. It didn't do that before. we are gonna get coolant everywhere, man. Oof, gross. Stop bubbling like that. Stop doing that. Oh, look at this. This is disgusting. I don't know why that's so gross to me. I hate it. Ah! Stop doing that. No! Oh! I don't know why I don't like that. I really don't. Not a fan. Okay. So we've zeroed. Let's check with our tool. This is tool number... Let's make sure our zeros look good with this tool. If we're on tool number 4... tool number 2. Oh boy. Man, I be getting crazy amounts of spam calls. I don't know what happened recently. All right, we're on tool number 2. That's pretty close. Oh, it thinks we're under. Okay, we're gonna reset our Z. I think I need to check my probe again. Who up checking the probe? All right, that's 0 on Z, but it thinks we're 40 thou under. That's crazy. That's nuts. So our tool length is off, which is a bummer. Yeah, it's like snot bubbles. It's disgusting. I hate it. All right. Unplug the limit switches. I can disable the limit switches. That's kind of a dangerous move, especially considering like who I am as a person. All right. Are we all ready? I've said that 6 times. Why don't we just start? Still get good footage, which is really valuable for like group projects. And then this camera back here is a Zcam E2. That one I got like a few years ago. It's a great bang for your buck, but it's hard to use. You can see all the fog coming out of the machine from the fog buster. It's a great bang for your buck, but it's hard to use. So we've got our center face off out. 1 second. Smells like cooling. Okay. So now we need to insert tool 5, which is a 16th inch end mill, and this one makes me really nervous. This one's very tiny. It's a really small end mill, and this is what we're going to use to bore out the hole the motor goes in. You have ventilation for that fog, right? You don't want to breathe it. Ah, yeah, that's a good point. I should get a fan. Dang it. All right, that makes sense. It's either a fan or a respirator. Dude, the amount of stuff that you're not supposed to breathe is crazy. Like, just let me breathe a little coolant. It should be fine. That's a joke, by the way, just so we're clear. Okay. I think I should also adjust the valve on the fog buster so we're not doing quite so much mist. Because this is like plenty, I think. No problem with the judgmental stuff. Let's open the garage door a little bit. Oh, no. There we go. That's what I want. Just a little bit. So that we have some ventilation, and then I'm gonna get a fan in here. We're gonna blow over the top of the machine. Yeah, this is the move. Nice. There we go. Okay, that's gonna help a lot. Okay. I've got the new tool. Let's see if this works. not like breathing stainless steel chromium cancer fumes or anything. So yeah. Coolant mist isn't too bad. It's only some oil-based ones for really hard matters. Yeah, and this one's like fine. It's just regular run-of-the-mill coolant stuff. What did you say the other cam was? Sorry, so this one's the Sony a7 III. Let me turn on. This one's the Sony a7 III, and then I have a Rode. Does it say what it is? Okay, so Rode makes a bunch of mics, and Zyla told me to get this one, and I didn't. I got the cheaper one, and then I hated it. So you should get this one. There's one that automatically turns on. So watch this. So the mic is on right now, and then the mic turns off. So there's one that automatically turns on when you turn on the camera. So I'm gonna turn on the camera now, and the mic turns on with it, only through the audio jack. You want that. You want that really, really bad, because otherwise if you forget to turn this on, and it's plugged into the camera, you'll have no audio and no reference and no nothing. So you want that feature. I don't remember what it's called, but it's a little pricey and it's rechargeable, but I've had to charge it like twice since buying it 2 months ago. 3 months ago. We had it for season's meetings. 4 months ago. Oh my gosh. 3? I don't know. But this is the a7 III. I really like it. I think it's great. And then that is the Sony, no, it's the Zcam E2 That one's okay. I sort of recommend it if you're like doing super big filmmaker stuff, but this is way easier. Comparable quality for YouTube. It just can't do the 4K 120 frames per second, which is fine. And I think it's like $1,000. I don't think it's 2,000. Maybe it's 2,000. They're all expensive, but this one's a good deal. Okay, are we ready? We're gonna do the whole now. Yeah, Rode Video Mic Pro, Pro Plus. If there's ever a time that we're gonna break a tool, this is it. Just so we're clear. I hate stuff like this. Let's get the fog buster there. So we have two ops here. We're gonna come in, do a single bore with, I think it's either 2 or 3 thou stock to leave axially, and then we're gonna come in and do that same operation with no stock to leave. So it's like we're roughing out the bulk of the material, and then we'll come back and just get like it's almost like a spring pass, right? Just so we get the rest of what we need. So here we go. Insert T5. Did I do it? Was that it? Wow. That? Okay. That was it. Man, that's great news. That was the one I was most concerned about. Now we're going for T7. Just a little chamfer on the hole. And now we're going back to T2, which is the 1/4 inch. Man, that's kind of an aggressive plunge. Okay, we plunged too hard. Yeah, I even said it when it happened too. I was like, that's kind of an aggressive plunge rate. How much is that end mill? It's not much. They're like kind of run-of-the-mill Tormach end mills, so they're fine. Well, that is good to know. We're gonna have to change that tool, change that tool path, and the stream is going to be a little bit longer than I thought. We're also going to have to get this out of here. Oh boy. Can I screw it out? Oh, this might be a problem. Okay. Yeah, this might be a problem. How do I remove a end mill? There we go. Carefully is the answer. Well, we didn't chip any teeth. The teeth look fine. It just was too much for the mill itself, or the tool. What am I trying to say? Like the shaft of it. All right, great. We got it out. So there's going to be a small break, which I did not anticipate, where we get another tool in there. Luckily, I have extras. Always have extra tools. This one is a 1/4 inch, 90 degree. That's not what I want. Hold on 1 second, folks. Okay, here's another square end mill. It's 3 flutes, and this is what we want. If you want to look up the part number, it is on Tormach, it's 37370. Let's see what I just paid. 37370. That was yes, 3 flute square carbide end mill. 31 bucks. Not great, not terrible. So we're just gonna have to look at the plunge rate on that. And we're gonna have to update all of the other tool paths, which is fun. Love that. So where did this go? Yeah, here we go. Here's the tool, the new one. All right, so first thing we're gonna do, we could use the height gauge, but we'll probably just use the some calipers. Let's go up. And while we're here, we can re-reference. Wow, look at that break. That is very pretty. That's really cool. Huh. All right, well, that's the first end mill I've broken on this machine. And you know what's crazy? It's the 1/4 inch, not the 1/16 inch that we just used. All right, let's replace it. Okay. Here it is. Here's the old end mill and the new one. And now we got to do a couple of things to get it ready to use. The first thing, I think I am going to use the height gauge. The tool length. Sorry, this is off camera. I mostly just want to get it done fast. Alright, at 0, tool length is 3.3545. So we'll change it in the offsets. 3.3545. That's the 1/4 inch. 545, and then I'm gonna be right back. This is gonna take like maybe 3 to 5 minutes. I'll be back, and then we'll run it again. And we're gonna get it right this time. All right, how are we all doing? It's been a hot minute. Did we drop off in viewers? Oh, we for sure did. Let's see. How are we doing? So, I have reset a bunch of stuff about the tool. We're on tool 2, and let's re-reference all of our axes here. Oh, and then I also changed the tool default settings and just backed off like the chip load that we have set for this tool in Fusion. So like it's all from templates, right? And the goal is that when I create an operation and toss a tool in there, the template fills out the speeds and feeds so that I like have speeds and feeds that I know can work, and that lets me manufacture things a lot faster, or like at least one-off parts. So now what I want to do, let's see what our 0 looks like on Z. We re-referenced everything, which means that we should be fine. That should be 0, and it's totally not. Is our tool length correct? We re-referenced. Do we need to re-0 after we crash? Do you think we need to re-0 after we crash? I re-referenced, which is not the same as re-zeroing. The re-referencing is like, all right, where are the stops? I need to re-0. Okay, I'll do it. I hate it, but I'll do it. That's going to be a little tricky, but we can totally do it. Let's reference off of this surface. And I don't even think... Oh, no! We do need to use the probe. Oh, I hate this. Okay. Luckily, we don't... Oh, this is really bad. Okay. It is super important that the hole in the center of the wheel is concentric with the rest of the wheel. We have already drilled the hole, and then we crashed the machine, and so some of the motors probably lost a little bit of like what's going on. So this sucks so much. I wonder if there's... It's not the Z that I'm concerned about, it's the X and Y. All right, here's what we're gonna do. I'm gonna get a new tool in there. We're gonna get the 16th inch end mill on 5, because if I can avoid, the stock isn't totally square. So if I can avoid, like if I probe off of it again, it won't be exactly where it was. So it might actually be better to not re-0 the X and Y and just re-0 the Z. We'll see. Oh, this sucks. All right, so what we're trying to see here is, are we close to the 0? Oh my God. Oh my God, because the 0 isn't in the center. Oh, this is so bad. Okay, so on Y, this sucks. I am not a good machinist. Let's get down on Z. Okay. On Y, that should be I don't even know what I'm looking for. I guess I'm looking for Y and X matching. All right, that's pretty close. 1.77 on both. So I actually think this is a little batshit. I actually think the best thing to do is to not re-zero the X and the Y and trust that the referencing is good enough. Use the hold to zero and offset. I don't have a probe that is small enough to do that. If the hole were larger, or if we had other features, we could do that. Using the CNC mill looks to be a very fun experience. I think it's fun if you're not the one doing it and if you don't care about the parts. Okay, the other thing that we could do there's totally a way to do this. And I just don't think I care quite enough to do it all the way. Like, I have a dial indicator that goes down to tenths, and there's totally a way that we could reference off of that hole, and I just don't think I care enough to do it. So I think we're not gonna. All right. We're gonna get the 1/4 inch back in there. My favorite thing ever, I had a conversation with someone about this like a week ago, and I told them that you should be doing B+ work. That doesn't apply to everything. If you're a surgeon, don't do that. But like, sometimes the best thing to do is B+ work because you need to complete the task, right? And so right now, I'm gonna do some B+ work because we have to get the parts made. And if the wheel spins up and it turns out there's a ton of vibration because that hole is not concentric with the wheel, if we're off center in the hole, we can make another one. I have more stock material, and I'll have learned a valuable lesson. But let's see if we can learn the lesson without learning the lesson. Does that make sense? Do you know what I'm saying? So the next thing that we're gonna do is reload the G-code. I posted it again, and we're gonna skip through it and see if we can find the right operation. Bah, bah, bah. So like that might be it. That's one of the adaptive ops. Oh boy. What is going on? This is nuts, dude. Hey, it's David from a company I won't name that I don't work with. Are you still in the market for working capital? We can also beat any offers you have. How much are you looking for? How about you market some... Never mind. Leave me alone, spam calls. All right, that's our facing operation. And we have a second facing operation. Right? I think I'm just gonna have to scroll through all this G-code. Okay, then we have the bore. That's real easy. Then we have the second bore. And then we have the drill and the 2D adaptive. So if I set to start at line 413 with this tool, I think this should work. This is tool 2. Are we ready? Do we trust my judgment on this? Give me an answer. Do we trust my judgment? Oh, I'm happy for you that the gunch is now always with you. Yeah, you want to see? Get my pants all pulled up. I'm not trying to drop trow on stream. This is gonna be really hard. Hold on. I guess I could pull down my pants, but I'd rather pull them up since I'm on the internet live. All right. See if you can. There he is. All right, there we go. May the gunch be with you all. This is how streamers get strikes. Let's do it. We did some of the adaptive. Now we're gonna do the rest of it. So specifically what I did is I took the feed rate down just a little bit. So the chip load per tooth is a little lower. We're at like 1.3 thou, I think, per tooth on the adaptive. Wait, yeah. The optimal load is like 8 thou? Is that correct? I mean, let's see. Oh my God, everyone, okay. Hello, Mr. Adams. Here where? Where? I am live on the internet. Do you want to say hello to the internet? Here, hold on one second. Say it again.
Hello, internet.
Zyla, tell the internet what you're working on if you want, or don't.
Working on a box of chocolate hazelnut cookies right now.
That's what's up next on the Zyla Foxland channel. She's working on a box of chocolate hazelnut cookies. Folks, can I call you back in like 2 hours or something?
Yeah, that's fine.
Okay, that's lovely. The internet says hello. I will talk to you all soon.
All right.
All right, bye. All right, that was great. Nice little intermission. Let's mill this thing. So I've set the start line, reduced. Oh, I also reduced the step down. The step down was like solid over half the tool diameter, and that felt like kind of aggressive, so we dialed it back. That's what we did. All right, let's see if we break another tool. I can afford to break. I actually think this is my last 1/4 inch, so I probably can't afford to break this one. All right. Oh, the spot drill. Stop. How about we start here? Why does it want the spot drill? Okay, let's start here. There we go. Yeah, I forgot to zero. I think this is it. Yeah, that's close enough. Right, and we're off by a hot bit there. So we're gonna zero the Z on tool 2. There we go. Now we can try that again. Where are we starting this cycle? I think this is the facing op. Yeah. All right. That's a load of garbage, so I gotta reset the start point. Oh, brother. Sorry, folks, this is gonna take a hot minute. I really wanted to keep this whole toolpath together, which saves time over the long term, because it means that I can just like run this op next time. But it means that right now I get the absolute pleasure of scrolling through all of my code to find it, to find the entry point that I want. And that has turned out to be kind of a bit of a chore. I must be close, right? Here we go. 2D adaptive, tool 2, 3 flute. The last one is the drill, so if we go to tool 2, let's try this, set start. That was a scary move. That's the one. Hey, that, it looks like our X and Y is fine. This doesn't seem... This is still too much. What am I doing wrong? Okay, hold on. I'm gonna go look at my toolpath. That's still like too much. We're plowing into the material 90% of the time, and that's not how adaptive is supposed to work. So something is wrong. All right, we're gonna try this again. My goodness. Load G code. Now this one starts on the adaptive. I've learned my lesson. I reduced the optimal load by like half, so we'll see if that helps. We're gonna cut air for a hot minute. What's good, Tiff? What'd it do? Something's really weird with this toolpath. I don't know what it is, but like the way that it cleared out the pockets first is super odd. Because like this is now way too light of a toolpath for the tool. Which is fine, like, we'll just wait a little while, but... CNC is dummy hard. Tiff was asking, what did I change? The thing that I changed isn't really what I thought I changed. So, like, there's this weird operation that we did first that doesn't... It's almost like it did the adaptive toolpath in the wrong order. Like, it should be doing one layer at a time, and instead of doing that, it's like plunging all the way down on some operations and then like going back up and then doing more things going down, which is weird. The load per tooth is supposed to be like 1.4 thou here, so it's really light for a 1/4 inch. This is just going to be super inefficient. We've got like 5 or 6 layers of this. Okay. Like that's a good adaptive sound. It's not slowing down the spindle too much. We're taking a good bite of it. Nice view. It is looking like a propeller right now. Yeah, it's like really slow on the ramp. And we don't need to be ramping down from what I think is like the top of the stock, but it really wants to do that. Well, I hope everyone's cool just hanging out here for a while. We're about halfway through the toolpath right now. It does kind of look like the radiation hazard thing too, yeah. There's not much else that has to happen here. We know once the adaptive starts working, it's pretty much either going to work or not. And it looks like it's fine now. It's just very slow. I can show you what we're working with. So you can see like what the machine's doing here. While this is going, I'm going to go ahead and check on the toolpath. I have one small itty-bitty concern about the when we contour out to actually get the final shape of the wheel on the outer edge. I'm a little bit concerned that we're going to plunge too hard on that. So I'm going to go check that. I'll be right back. How we doing? Seems like doing okay. I did change one thing. So before we do our final contour around the perimeter of the wheel, it's not the feed height for that contour is too low, and we are gonna almost for sure break the bit if we do that. So I'm glad I caught that. looks like we have 2 more adaptive passes here, and then we can move on to bottoming out the floor. Extreme close-up. This pass, you're going to start to see the shape of the wheel, which will be cool, or like the shape of the spars in between it. Can I rate your username? Yes. Flight Termination System as a username that's like an 8 out of 10. Someone says, Sasquatch Composites. You're in California now, right? Which part? I'm down near the LA area. Which is really good for like Friends of Amateur Rocketry. Lucerne Valley isn't too far. And then there's a bunch of aerospace stuff around here too, which is great. What's my favorite non-electrical tool? Right now, I like deburring tools for reasons that might be obvious. I also I have this Z-Bend tool. If you go on Amazon and just look up Z-Bend tool, you put a piece of steel wire in it, and then you clamp down, and it makes a Z. It's awesome. That's a nice adaptive sound. A boring fan gets a 7 out of 10 rating in terms of a username. All right, so this next pass is going to go to the bottom of the material, but that depends on the resolution of our initial Z estimation and our estimation of how thick the stock is. So this next pass might break through, and if it doesn't break through, we have a contouring operation right after it that will break through. Oh, we broke through! Nice! Do you guys want to know a fun fact? See how it's red under the... see how the wood under here is red? Do you know what the red wood is from? Wow, I can't talk. Take a wild guess as to what this red wood is from as a wasteport. So what about the other side? How on earth do you align it? We don't need to align it. It's a 2D operation. Or I guess it's 3D, but we don't need to do any other operations on this part. Season's Eatings! That's right! I have a bunch of extra wood from the fins, and we get to use it as the waste board. rate my own username. My own username gets a 4 out of 10 because it's unoriginal. Alright, so after this operation, we're going to come down and contour the inside, which is going to clean up some of the stock around there, and then we're going to stop the tool path and load a different one that's going to come down and contour out the rest of the wheel on the outside. It's going to give us some tabs, and then we're going to be done with the wheel. Small bites off of this wheel because we left like 3 or 4 thou of stock, and so what we're doing is we're coming in and we're just cleaning up little bits of it. I don't know why we're doing it this way, but it kind of is what it is. Whoever made these tool paths did a kind of trash job. Alright, I'm not rating any more usernames. Thank you, though. Get him, Tiff! Damn! Get his ass! Alright, we're cleaning up around the wood. And then we're going to stop this operation pretty soon. Yep. Stop. Okay. So this next one is going to cut out the final wheel shape. You can also get some of this wood out of here. Very nice. That looks good. Oh. Well, I goofed up on the inside of the wheel. We would do well with like one final facing operation there, but I kind of don't care enough, and that part is not going to see the light of day. So I think screw it. We're just going to leave that. Also, the tool still looks like it's in good shape, which is great. So now we're going to come around on the outside and contour wheel. And so this operation is just going to go around the outside, plunge through the stock, and cut out the shape. How much mass are you aiming for this wheel? I think Fusion told me it'd be like 30 grams. It's pretty lightweight, but almost all of that mass is concentrated on the outside, which is the important part. Are we all ready? Is everyone ready for me to cut this out and maybe break another tool? Maybe / definitely break another tool? Let me get another little bit of B-roll here. Okie doke. Let's do it. Cool. We're gonna cut a decent amount of air with these first few things, which is fine. We kind of want that. Okay, see how it's going into the stock? We didn't face off enough before, and so I want to start it high so that we even out the contouring. That's exactly why we did it. I'm also slowing down the feed rate a little bit. These are beefy cuts. I'm at 70% of the feed rate that I set right now. And we have one more for good measure here. We're just cutting wood. Woo! Let's go. It's Joey B. Only breaking one tool. So there's one part that I didn't quite get. Ooh, it's warm. We be cutting. There's one part that I didn't quite get, and it's these little bits here, and I think I kind of want to fix that. We've already got the part in there. It's all zeroed. What we should do is create just a small little operation, and these like little humps in the center, I just want to clean those up so that it looks perfect. Yeah, I really want to do that. and then we can be done. All right, BRB. Is this still rolling? I think this is, no, it's not. Okay, BRB. Here we go. Real quick, we're gonna load the G code, clean this thing up. That's the one. Cool. All done now. So this is the final wheel, which feels good. It's clean on the bottom. The edges are very sharp, but we're not going to chamfer them because it doesn't have any big purpose. The edges that I'd want to chamfer are not edges that I can get from this operation. We'd have to turn it over, and I don't really want to do that. So we're going to take it off. Man, I do need an air gun. All right, chips everywhere. All right, let me clean it up with some acetone too. This looks really good. So you also get to see the fancy little thing that I did yesterday, or was it earlier today? It wasn't on stream though. And the fancy little thing that I did is I actually faced. All right, let's do this. So I actually faced off both sides. I did this side too because I wanted a nice surface finish. This side is the side that we're actually going to see up top at the top of the wheel. This side we're not going to see. So all this pretty work is actually going to be occluded. Let me record some of this too. But yeah, no. So I faced off the other side, and it's going to look really nice once we get those tabs out. Cool beans. All right. So we can do a second part if everyone's up for it. I got time. Do we want to do a second part? We can do the housing. And it's going to take a couple of little operations, but we can totally do it. Do it? All right, Tiff says do it. Anyone else? Any other votes? Gosh, this looks so nice. I actually think the tabs were the right size too, which is a shock because I thought they might have been too small. We can also, oh, I don't have an extra motor to check. I'm gonna heat set this on camera, but off stream, because that requires an amount of work. Really glad I came in and cleaned up those faces of like the spars. Here's the part in the webcam. Looks so pretty, so shiny. All right, people want me to do it, so I'm gonna do it. Hollow CNC parts. Man, this is awesome. You can hear it. Wow, yeah, it's got like a natural frequency. Tell me if you can hear the ring of this. Isn't that cool? Oh, there's like a chunk out of this part. I do not know what happened there. All right, well let's do the next part. So we've made the wheel out of this piece of stock material, and now we're going to make the housing for the wheel out of this piece. So the housing is going to go around. It's going to protect the sides of the wheel, and it's going to hold the motor. And that's it. I need some more coffee. Who up drinking coffee? Oh, we actually need to put the vise on for this too, so we get to do a little bit of a work holding change up. Man, I'm running out of air in my canister. I'm gonna have to get a new one. Oh, I could just use the shop vac. Let's vacuum up some of this stuff instead of just spraying it everywhere. I'm cleaning my hands. That's all this is. Good. All right. So what we need to do now, I'm going to take some of this work holding stuff out. You can actually just move these to the side because we are going to need them later. But we need to put the vise down. The good news about the vise is that we don't actually have to dial, indicator, anything in, because this is just, we're removing like a decent chunk of the stock. You'll see what I mean in like a hot second. First, we're going to make sure that we have a flat surface. That is important. No chips or anything like that. Okay. Then we're going to put the vise down, which is exceedingly heavy. God, jeez. Make sure the vise is flat, which it is. And then we're going to bolt it down with these weird clamps. Because the clamps that it comes with don't fit super well on the table, so we use these little guys. Come on, buddy. Get on in there. Get in the T slot. You put the peeps in the chili and add the M&Ms. Come on, get in there. Bro, I'm gonna scream. There we go. So the only thing we want to super duper make sure here is we're going to check the travel. So for the stock, we're going to use this piece, which does not fit in the clamp. Oh, damn it. So we can take these jaws off. Can anyone tell me if I'm gonna hate myself if I take one of these jaws off to fit the piece of stock in there? It's a 4-inch vise, but like effectively right now it's a 3-inch vise. And this stock is more than 3 inches wide. Am I going to hate my life if I do that? Also, can I? I don't even know if I have the right tool to remove that. Yeah, follow-up question. I don't think I have the right tool for the job. Nope, not a big deal. Yeah, it's an Allen key, but I don't think I have a large enough Allen key. Which seems weird. I feel like it would come with one. I almost feel like this might turn into a stream where I go to Harbor Freight halfway through. Oh, could it be this? A bunch of work holding stuff. Yeah, I don't know that I have a large enough Allen key. Flex tape it. Oh, just put thinner parallels on the vise. No, the problem is it doesn't even fit in the vise. So like I want to plane this, and the clamp doesn't go far enough back by about a 1/2 inch. So if I removed one of these, it would work, but I don't currently have. I could make my own Allen key. That would be dumb, but I could do it. If I didn't want to stop streaming, I could make my own Allen key. What else do I have in this garage? Will the vise not open any further? No, the vise will not open any further. The floating jaw is as far back as it will go here. Shorten the stock. So the problem with shortening the stock is that we cut into... Oh! Okay, we might be able to get away with shortening the stock, but it would have to be like a whole 1/2 inch. And the problem is that right now, we're cutting this out for a 74mm airframe. The stock is 76mm. We're already cutting through one of the edges of the stock. Like we have 3 tabs on either side. Yeah, so we can't shorten the stock. This is a fixed size of stock, and I want to face the whole thing cleanly, so we can't do the clamps that go down on the top. I have a different vise. I am now just seeing I have a different vise. Hold on. There's been a change in the game. I have a different vise. It came with my drill press. Oh my god, this will totally work. The game has been changed in a way that the game is changing. And this doesn't even have to be that accurate. Like the jaws here are rubber, but we just need to face it. So we're not caring about X or Y precision. We just care about Z precision, and that's going to be fine. Someone says, don't use that. Tell me why. Why shouldn't I use it? Give me one good reason to not use this piece of junk. Give me one good reason. Because I'm gonna start doing it, and if you can't find a good reason, it's gonna happen. My name's Joey B. Can I take all the rubber off? Probably could. If I really wanted to? Yeah, it's just Allen keys. But I don't really want to. Go for it, entertainment. All those who want to see Joe build a centrifugal compressor wheel instead of a reaction wheel, please stand now. No one better stand. No standing. All right, I'm going to clean off the vise. I'm going to clean off the table again, and we're going to mount this thing. This is great. I'm so stoked about this. All right, the vise is clean. We'll redo cleaning on the table. Get any chips off of there. All right. Are we feeling good about the sketchy vise? You know the brand is Wen, by the way, W-E-N. It's a Wen vise. If it's stupid and it works, then it's not stupid. Will that be enough? Question mark, will. So we're just going to clamp it on that and on this, and it's going to be sketchy, but nobody is going to say anything Because I am a genius. Let's also get these chips out of here. Man, I am such a big fan of this vise. This is one of the best things to ever happen to me. We're gonna make sure it's real tight though. I think that's good enough. Man, this is awesome. I'm so excited. It fits. We're gonna need some parallels on this because we're clearing off more than that. Let's try these. These might get it up a little bit too high. Oh my God, the jaw goes up when you clamp it. Ah, that's so bad. Okay, all right, that's too high. The parallels are too high. You know that TikTok sound? That goes, time to do some sketchy shit. Doo-da, doo-da, hope I get away with it. Doo-da, doo-da, day. That's what's happening here. So we're doing some sketchy shit. I'll remind everyone, this doesn't have to be perfect. It just has to work well enough. That's what we're going here. That's what we're going for here. Is good enough. And if this doesn't work, if it still goes up, yeah, it still lifts it up. Oh man, that's not a good vise. Okay, you know what? Let's play a game. Let's play a game. Let's play a game called Quantify the Error. Because this doesn't even have to be that good. What it has to be is like, hold on. So, how am I going to do this? We can just put it on the table, can't we? Yeah. All right, so we're going to get a dial indicator. We're going to find out what amount of error do we have here. Because we all know it's not 0. All right. So this is in tenths. All right. Are you ready, kids? Aye, aye, Captain. I can't hear you. Oh, that's not that bad. That's... It's not awful. I think it's fine. I think it's fine. All right, that's nice and tight. We're gonna change the end mill to this bad boy. Oh! Let's get the Superfly. This thing is awesome. The Superfly is a fly cutter like this. It's really cool. All right. How are we doing? How are the vibes? I never got the coffee, did I? Should probably get that. So we're gonna come up with a little cheeky tool path here in a thing called Conversational Milling, which is where you have a conversation with the milling machine. It's gonna be great. We're all gonna have a lot of fun. Okay? So, we're facing, the tool is this guy, tool 6, fly cut. Tool 6, we're gonna do rectangular facing, I guess we could, no, we're doing rectangular. So now we're gonna set the starting and ending points. Let's make sure we're on tool 6. This is gonna take a hot minute here, folks. That's 0 on Z. Right, okay, we got new zeros. We actually don't care about the X and Y zeros. So we're just gonna call this X and Y 0. Our axes are still referenced. The X start is gonna be here, which is negative 0.36. 36. X end. Going to be this, which is 5. So we're just kind of hacking stuff together here. The Y start. Y start is here, which is 0 basically. And the Y end is going to be here, which is 3.68. The Z start is going to be 0. The Z end is, we're going to have to figure out how much we're cutting off. Let me get some calipers. Okay, Queen Bosses, how are we feeling? Our stock size roughly speaking, 1.5 inches. We need, so if that's 0, what is 1.5 minus, it's actually 1.523, but that's fine, minus 0.9055. 0.9055. So it's a little bit more than a half inch. Let's just cut off a half inch. And then we can dial it in a little bit more as we get closer. And then we can flip it so that both sides are pretty. That's what we're gonna do. We're gonna cut off a half inch. Z end is 0.5 with a negative. Depth of cut is whatever. This is going to generate stuff. 60, 61. Depth of cut, we're gonna go a little bit less than that. Try that again. 0.45, how about we go 0.35? Oh my gosh, please. 0.035, and the step over, that feels like kind of a lot. Like for the fly cutter, let's try it. And let's say the Z start is 0.1. Post, Y start must be greater than Y end. Oh, our, okay, so Y start is 3.6868, and this needs to be 0. Post. To tests, fly, cut, 1. Cut 1. And that's what it looks like. All right, should we try it? Is everyone feeling good? I'm feeling okay, if I'm to be honest about it. I'm feeling a little worried that, you know, we'll see if this works. Yeah, we'll see if this works. I'm not totally convinced. We're taking off a half inch. Yeah. Let's see if it works. We've got a little room to spare, but this will get us down really close to what we want in terms of our sizes. Or like our stock size. Whoops. Before it actually happens. Did you change your Z start? Yes, I did. I changed it to be a little bit higher than the stock material because I wanted one pass at least that's like this, where it's not actually cutting anything, and I wanted to make sure, like, does it look good? And it does. It looks pretty good. What's squeaking? It's a cool sound. Alright, so we're gonna slow the feed down just a little bit in case we hit the part. That's okay. It's alright to be like a little conservative with it. Yeah, I probably shouldn't be putting my hand that close. My bad. And while this is happening, I'm going to slow this down a little bit and get some coffee. Alright. This might be it. I'm at 100% feed right now. Got like 6 depths to cut. So we're taking kind of shallow passes. Oh man. Oh, here it goes. It's happening. Wow, these are really light cuts. So I'm gonna speed up. Oh, it's a mirror finish. That's very pretty. Oh, good night, Mark. It's a mirror. You can tell that it's that the stock isn't even because we're not hitting it on the back passes. That's okay. That's what we knew, right? It raises up just a little bit. We knew. We've been new. All right, and once again, I'm gonna dial back the speed. Ooh, that's a pretty noise, man. All right, where's my coffee? CNC, this is the most burr that the CNC has gone so far. CNC do go burr. So someone is asking a really good question here. Fee says the only problem with this is if he needs the top and bottom to be parallel. With that vise, they won't be unless he can counter the jaw rise when he flips it, which is a great point. The good news is that I don't need these to be parallel, because what we're going to do is when we get this back on the table in the way that we actually want to mill it for the final part that we're making, we're still doing a facing operation in that. So we will naturally level the part. Like no face that we're milling right now will be exposed on the final part. Oh, sorry, that's not correct. One of these faces will be exposed on the final part, but it doesn't need to be parallel with the other face because we have a facing operation that we are going to do as part of the whole cam path, if that makes sense. I am not wearing ear protection. It is not that loud. Even the compressor is like behind the CNC. The funny thing about this is this machine is far quieter than my little desktop mill, because the desktop mill is like screaming as it goes. It's like screaming and chattering, and it's like, ah! And this one is just, this doesn't care about cutting metal most of the time. It's built to cut metal. The desktop mill is really more for like wood or acrylic or Delrin or something like that. And this is built for metal, so the machine is not vibrating a whole lot. You've been streaming for 2 hours and you're still cutting down the stock. A true machinist. Yeah, that's a good, yeah, having more mass really helps, because the machine won't vibrate that much. Let's see, the other thing I wanted to point out is, this is taking a long time for this part, but it's worth noting that, like, I could do this in, you know, maybe not that much faster, but I'm still learning how to do CNC. Also, I really want to record this. I'm still learning how to do CNC right now, so a lot of the, like, you see me go back and forth changing tool paths and trying to, like, mess with things as we go. Oh, it's so pretty. Trying to, like, mess with stuff as we go. And that becomes a lot better as I get better at the practice. Any other metal parts for Scout F? Yes. So the landing legs need a few metal parts. The landing leg base and then the strut retainer that takes all of the load on landing, or takes some of the load, those are both out of metal. They're both out of aluminum. And then there are a few brackets that I need to make that are also aluminum. Material removal is usually a bandsaw, but I don't have a bandsaw. I do have a chop saw that I bought for material removal, and I could have done that. We could have clamped it so this could happen in a safe way, but the finish from a fly cutter is really pretty, and so I think we're going to just stick with this for now. We're about halfway through the facing op. So this side that I'm making now, I think we're gonna make this the bottom. I'm gonna tweet a picture. All right, one of those is going to work well. All right. I'm gonna get another angle here. We're about 60% of the way through here. Okay, good action shots. Nice work, everybody. It is a good guess on the lens. It's a 24 to 105, so it's the cheaper of the two. So it's f4. I am using a speed booster on the Z-Cam though. The speed booster sort of like increases the effective aperture, sort of. That's beyond my pay grade. All right, we have 2 more passes. Oh, good night, cover. Why use the fly cutter for the stock removal? Why not use a 1-inch carbide end mill? Absolutely sand it and then leave 10 thou left and fly cut that. Because I don't have a 1-inch carbide end mill. That's why. Also, I could have done it with like a bandsaw. I don't have a bandsaw, but I do have a saw that could do it. But you're forgetting one crucial piece of information. I'll let you think about it, and then I'll give you the answer in a second. But you're forgetting one crucial piece of information. Take a wild guess. Put your guesses in the chat. What's the one crucial piece of information as to why I'm not removing material in a different way? All right, I'll give you the answer. The one crucial piece of information is that I'm dumb. Or not so much dumb as just I didn't think of it. Unbelievably pretty. Look at this. Here, I'll leave it there. Wow, man, the white balance is crazy. Look at these chips. They're perfect. Yeah, it's tinsel for next year's season's eatings. That's a good point. Danger pasta. I don't know what's dangerous about it. You guys don't cook this and eat it? It's delicious. It's good for you. It is gluten-free. So true. So true, dude. All right, we're almost done. You can see the tool path here if you want. It's just like an S. Whoops, sorry about that. BPS lore. Wrong channel for it. Aiden says, dude, I just started my new job doing CNC lathe work. This is great and happiness. Oh boy, listen, if you want to keep your job, I have a pro tip for you. Don't take any advice from whatever I say on this stream. That will help you keep your job. All right, a few more passes. Definitely not the right way to remove material, but this is the way that I've committed to. I wish I could do something useful with these chips. Someone is talking about the razor sharp chips you get from steel. Yeah, I haven't done any stainless or any steel yet. It might be in my future, but just aluminum for now. I was saying I wish there was something cool that I could do with these chips. I could sell them back, recycle them, but also so in thinking about the space shot stuff and thinking about ways to fund the space shot, I thought I could sell chips from making the parts for the space shot. But the problem is that the chips don't go to space. The chips are explicitly not the rocket. They're the thing that was removed from the rocket. So I was thinking we could fly some of the chips, I guess. And if you wanted some chips flown in space, but that's kind of weird. I don't know. Oh, I could melt down the chips and cast stuff. That's actually a great idea, and that's a very accomplishable thing. I could get a little kiln. That's a really good idea. To melt down the chips, so we'd take all the chips from the space shot and we'd melt down something. That's a really good idea. Yeah, cast aluminum statues would be cool. All right. We're almost there, folks. Rome wasn't built in a day. But also, we have a lot more technology than they did, so we should be able to go a little faster. I got the 2020 mode. Stop it after this pass. Oh, coins are a good idea too. We could do little coins. That would be a good idea. Someone says I should grab some carbide end mills from work and send them to you. Listen, I won't turn them down. Wow, we've been going for almost 3 hours. We have at least another hour of work to do. Sorry, did I miscredit someone? Sorry, Fishy. My bad. That's on me. Oh. There we go. I'm not gonna do the last pass. It's not worth it. Yeah, it's not worth it. We have what we need. Let's go to G30. Our end mill looks fine. Yeah, the carbide on it still looks great. Oh! Oh! Oh my gosh, I'm illiterate. Hold on. This? That is... Man, that's like one of the most wonderful surfaces ever. I'm sorry for slapping it. I shouldn't have done that. Nick, cut that. Get that out of there. That's really nice. Wow. I love that. Yeah, I really love that. Whew. All right. Let's get it out of here. Here's our stock that we painstakingly fly cut down. We have a little bit more to go, I think. But I'm gonna measure this and see if we can just update the toolpath so that we can start actually getting the wheel, or the housing out of here. Let me get some acetone and wipe this down. Gosh, it looks great. I am obsessed with the surface finish. Oof! Some of those chips are sharp. That does make me glad that I'm not doing stainless or anything. Okay, check it. So this is the surface that we have. Let me get a recording of this. This is the surface that we have, that we made. This is the extruded surface. So that's what we're going to mill down next. This is going to be the bottom. This looks great. I'm pleased with it. And like someone said earlier, like it's not going to be parallel, but that doesn't matter because we start off with a facing operation on this anyway. So it's like, what's the point? Let's get the shot back first. Vacuuming up all the macaroni. My parallels. That would have been awful. That would have really ruined my day. Okay, let's play a game called This Unscrews No Matter What. Okay, we're just going to move these out of the way and leave them. And then we're going to move these in to use them on our stock. Everything is coated in a thin layer of coolant, and it's disgusting. Okay, wipe it down. Okay, that's great. What else do we have going on here? Okay. So we have our stock. This is going to go at the bottom, but obviously we can't. Ooh, that is nice and flat. We can't just put it there because we'll cut into the table, and I would hate to do that. So, good news. Guess who has plenty of old fins from Season's Yeetings? Boom. Just like that. It's not perfect. I don't want to hear about it. Is someone outside? Hold on. Okay, someone was outside. Amazon. Where are my calipers? Where upon whence did they go? Oh boy. Okay, hold on. Oh, there they are. So I want to know the size of my stock. First, we're going to zero it. It's 10.39 on that, and 10.53 on this. So this is actually like a decent slant. We're going to assume that it's all 10.53 and start from there. Or 1.053, that's what it is. for the delay there. Just really wanted to make sure that was right. And good news, I don't know where my stock material went. Well, I'm built different. Worse. Hold on 1 second. Bro, where did I put my stock material? I'm asking. Does anyone remember where I put it? Oh my god, it's right there. Okay. So, this has some dust on it, but I think it'll be fine. The wood's gonna collapse when we clamp down. I do want longer clamps on those though. These are like comically large. Alright, we'll work with this. I need these things. The stairs, I guess you'd call it. Okay. Now, the good news is we don't have to be crazy accurate on a couple of things. Like the alignment of the stock to the table, not a thing that really matters for us here. Yeah, not a thing that we're that concerned about. Huh, okay, that doesn't work. Why does that not work? Because of the wood. All right, let's cut down our waste board a little bit. BRB. Glasses on. Before this happens, look what I'm doing. I am a personally protected king. Okay? These go on before you cut on a saw. And stay strapped. Let's see if that worked. Should work well enough. Yeah, that's all we need. Ruh-roh, we need a bigger set of stairs. Can someone help me? What are these called? I am calling them stairs because they look a lot like stairs, but like, what is this supposed to be called? Okay. That feels okay. We're going to back most of these clamps off. Just a decent amount, because I really don't want to mess this up. Oh no, I'm stupid. I'm actually illiterate. Okay. This is the wrong side. I'm glad I didn't cut on this side. That would have been really disappointing. It goes here. It goes here. Cool. All right. These parts are going to be very nice. And even if they aren't, you have to tell me that they are, because I'm working very hard on them. So I need to feel good about the time spent here. I'm also biting on a very small piece of the material because I really don't, I never want to crash the machine into the work holding. It would make me feel very sad to have that happen. Okay, that's good. How well is it aligned with the table? It doesn't need to be perfect, but I would like it to be, there we go, that's a little better. Okay, great. Excellent. Thank you. No, it's actually good. I wanted my pliers to fall into the sharp chips so that I could grab them out. I actually wanted that to happen. So that was really good that it did. Thankful for that. Please just clamp down, you big Goomba. I got other things to do today rather than just like this. Okay, there we go. That's what I want. Do the same with this. All right, we're getting there. We're getting there, folks. Door stops? Let's see. I missed all of the things. Vertical lathes? No. Bigger stairs, door stops, thingamajiggers. Bro, what's up? Ramps? That sounds likely. The entire thing is called a toe clamp. What? No, we did this earlier. And someone said, no, toe clamps only bite into the side of the material, and we're biting down the top. I thought they were called toe clamps, which means I'm not wrong, which is good because I'm 100%. I've never been wrong. McMaster lists them as step blocks. That sounds the most right. What are you doing, step block? Sorry. I'll shut up. Okay. Oh, I still have this on. Sorry for that. My apologies. Let's clamp these down all the way. Much like every other operation I've done so far, this doesn't have to be perfect, but it does have to work. That's good enough. If I can shake the machine with the stock, I count it as good enough. What do you think the first tool that we use in this operation is? Wheel housing, load G-code. We are using 3 tools: 1/4 inch, 1/8 inch, and the spot drill. That's great. Okay, so 1/4 inch is first. This is a hard tool to remove. There we go. Longtime fans of the channel will know that we broke a bit today. You have to be following the channel for a very long time to know that, though. I'm about to clamp your toes for saying that. Damn, bro. Get his ass. All right. We got the 1/4 inch in there. Never mind. She says these things. She said these things to me. What else do we need? I'm gonna remove these, I think. We need to probe the material, which is to say we need to set our zeros. I actually think we can do this without probing it. The probe is always cool and it looks nice, but I don't think it's really needed here. So let's just do it this way. That's about the center of the tool. So this is going to be our X. All right, that's 0 on X. Hold on. There we go. Heard a weird noise for a second. That's about the center of the tool, so that's Y, 0. Right? And then Z0 gets set very carefully. Should we do the paper trick? We should do the paper trick. You know what I'm realizing? Z0 doesn't need to be set that carefully. What we do need to do is find the high side. So check this out. This is gonna take a minute, but it's gonna be worth it. So, this is super janky. Hold on. Wait, I kind of want it on that side. One day, I will do something right the first time, but not today. All right, check this out, queens and bosses. We take a cheeky little dial indicator, we put it near the center of our stock. Check this out. All right, we got that. Let's slow down our jog speed. All right, that's close enough to 0. Right? If that's 0, and then we go along the y-axis, look at how out of line that is. These are in tenths. But we are decidedly not parallel. Right? So what we want to do is take the high side So we want to probe off of this because I measured the high side of the block. You know what I do love? This little magnetic block that holds the dial indicator. It's awesome. All right. So when we do the paper trick, I'm sorry this is taking forever, but promise it's worth it. We're going to take it on the very edge of the stock. So I'm going to go down in increments. We're going down in really small increments. Little engagement. Very precise. There we go, that's what I want. Okay. That's pretty much scraping the paper, so we're gonna call that 0 on Z, but we also need to make sure we have the right tool, so I'm on tool 2, Z0, and offsets, I'm gonna make sure this is the right tool, which is the 1/4 inch flat end mill. That's true. So we're good. Go back into continuous, up the speed. Okay, I feel good about this. You should honestly still be using a vise for this. If you want that part square, the wood would throw you off. You will see why that you are wrong. You will see why you are wrong when the part is finished. We're gonna split this part in half. So it would be appropriate to like clamp down on this side and clamp down on this side, but the wood is gonna be the best thing for us because the vise, by the end of the part, if we used a vise, it would collapse in on itself. Okay. Someone needs a spindle indicator holder for Christmas. Yeah, maybe. I feel like I have so plenty of the I have so many tools right now. I've got like plenty of tools. I don't think I need any extras as it stands. Maybe some of the clamps that go on the side of the aluminum. Those would be great. So we've set our zeros. That's like X0, Y0, Z0. Our zeros are in the corner. I'll show you what we're making. So, you can sort of see what's up here if I put it in the center. This is the housing that we're making. There are a lot of tool paths for keeping the step downs really shallow. There's a bit in the center for the motor. This is where the motor is going to go, right in the center. And then we're pocketing out 4 things. So this is quad symmetry instead of tri-symmetry, like the wheel. We've got little, stays to keep the motor in there, but everything else gets pocketed out. And then we've got very thin walls around the side. And those thin walls are going to hold the wheel in the top of this, so that if any cables need to pass by the side, you'll see what happens, but if any cables need to pass by the side, they totally can do that. We clear like 2 or 3 millimeters on the side. So that's that. Is everyone ready? Should we run it? We've got the op in there. You know what I am going to do before we do this? Get a new camera battery. I'll be right back. Okay. Don't freak out. You'll get the angle back in just a second. All right, should be coming back in a little bit. Give it a minute, there we go. Excellent. All right, on a scale of 1 to 10, how much do you believe in the work that I've done here? What I mean by that is, how much do you believe that we will avoid crashing this thing? Crashing means breaking an end mill, doing something dumb, having a bad tool path. Give me a 10 is I'm gonna pass through with flying colors. 1 or 0 is the machine will catch on fire and it will burn my house down and me with it. What are we thinking? Oh, JR Craft, thank you for the $1. He's donating to the Toe Clamp Fund. Doing something dumb is kind of your brand, so who knows? 11. Tiff has a lot of confidence. Let's see. 9.39, very specific. JR Craft gives me a 9.99 out of 10. A lot of 11s. There's a lot of faith in here. Y'all have a lot of faith in me. This is great. I also shouts out something that no one's going to care about. I have not dropped a single frame on this stream. I'm hardwired through Ethernet. Your boy is getting better at streaming. We have not dropped a single frame. And we're at like 6,000 kilobits a second. So or megabits a second. Kilobits a second, not megabits a second. Shouts out to me getting better at streaming. Over the course of, what was it? 3 hours and almost 30 minutes, no dropped frames. Okay, ready? Let's let me get some of this gunk off here. One second. I'm gonna wipe down these windows. Alright, that and then a dry paper towel should do the trick. Should clear right up. Boom. Excellent. Pretty clean. Okay. Here we go, folks. Godspeed. Good luck. May the gunch be with us all. So the first thing we're going to do is a facing op. And this is going to even out our material, which is not even right now. Not even a little bit. Let's also... Hold on. I'm just going to do one more thing to make sure we don't hit a clamp. Woo! Okay. We're good on this corner. What I'm doing is I'm checking the tool path. And we're good on that corner. We're good on that corner. We're good on this corner. I'm gonna change the X0 just a little bit. There we go. So now we're a little further from these clamps. Make sure this is good here. That looks fine. That's our edge there. Yeah, this is all good. Okay. This is good enough. Oh, we might hit the clamp on the way down. You know what? That's distinctly possible. Okay. let's just take a quick measurement. One day we will start cutting, I promise, but need a hot minute here. All right. That's good enough. The tool stick out is like 1.2 inches. And we have less material than that. I really don't want to mess with the tool, but I kind of think we have to. Oh, I kind of think we have to mess with the tool. All right, how would we actually do this? The tool stick out is 1.2 inches. When we're down here, we will absolutely collide with the clamp. Okay, yep. No, we need to change the tool. Damn it. Let's find out how tall this has to be. It has to be tool needs to stick out like 1.7, which is kind of a lot. Wow, that is a lot. I hate that. I should have cut a bigger piece of stock. I might change some of these tool paths to be a little bit more chill. Yeah, I'm pretty worried about that. There we go. That's pretty good in the collet. We're gonna remeasure the length. .79. Okay. I hate that. We are 100% not choked up on the tool, and I hate it a lot. We're gonna change the aggressiveness with the cutting too, so I'm gonna go do that. It's gonna take a little bit longer. It's gonna save us the tool because we lose a bunch of rigidity now. Okay, 1 second. All right, we're almost ready, folks. We're almost ready. We want to do this in one pass, so I've slowed down all the rates. Let's try it. We're in Tool 2. Make sure this looks like 0. Yeah, we need to reset zeros. Maybe one day we'll start milling. Maybe one day. Where did that piece of paper go? Here it is. All right. Z0. Is everyone for real? All the way ready? Just killing me. Let's do it. It's happening. We're doing it. So the depth is getting shallower and shallower here. And what we're doing is we're taking these facing ups. We've got 4 steps to go down. We're going to take them nice and slow. So it's going to take a hot minute. Joey Murphy asks, Mr. Barnard, are you adequately hydrated for this operation? And I gotta say, Joey Murphy, excellent question, because the answer is no. So let's change that. Had 2 big cups of water, and now I've got a little seltzy boy. Yeah, so we've stopped cutting. That's the evenness of the surface, or the unevenness, I guess. That's a deep cut for how long that tool is. I'm keeping the speed really low, so we're probably generating a ton of heat, but that is a deeper cut than I was expecting. So we're just like not gonna mess around. I'm also gonna cool it a little bit more, I think. It is a plunge for sure. I just really don't want to break the tool. The motor is not struggling. I manually dialed down the RPM. So I can go to a lower or higher RPM, right? That's a lower RPM. If we wanted a little less heat, and a slightly higher like chip load. This actually might be a better sound. The chips are very small. Yeah, not a fan of this. I just really, we're pretty close to those toe clamps once we get further down in the block. So we're gonna take everything else really tame because the tool is like not well seated. What coolant am I using? bad boy. Extreme cut, 251Z. I mean, I do, like, I'm not proud of this operation. It's not awful. New glasses. Yes, they're like more subtle. I kind of like them. Halfway through our facing operation. We have 2 more levels to go down, and then we're at the top of the part, and then we start a 2D adaptive, which is going to start to clear out all of the stuff we don't want in here. The chips are okay. They're a little tiny. So maybe I want to slow down the spindle if the chips are small and I don't want to push it faster. Is that true? Can someone vibe check me on that? If the chips are tiny and I don't want to push the end mill harder, can I slow down the spindle? We could face with the 3/8 end mill, but it's too late because the operation's already in work. After the compressor turns off, we're going to slow down the spindle and take a look at the chips and see if they look any better and if it sounds better. Right now we're at 8,500 RPM All right, we're gonna slow down a little bit. That's 7,500. I don't know that this is really what I want. I don't know. Yeah. Yeah, I think we'll leave it here. We've only got one more pass to do with this. And then the other thing that will be difficult for the tool is a contouring operation. But I think in the future, what I'll do is I'll just plan better to account for the tool holder diameter when I cut stock for clamping it down, so that we can put the tool holder right against the top of the stock instead of having to compensate for these tool holders, which is what we're doing right now. My guy, eat whatever you want on pizza. It's okay to like different things. You like the peeking, Perry? Is that good? Is that good for you? You into that? You guys want some Joey B ASMR? You guys, you want some Joey B ASMR? looks like milk. Carbonated coolant. Someone make the joke. Me losing my mind every time someone comes up with the comedic genius to suggest that I carbonate something. Clipping too much when on the mic. Sorry, are you serious? You think this is clipping too much? I taught myself how to burp when I was a kid. My sister and I were in the car while my mom was shopping, and we just like kind of figured it out. And so I can do it on command now. I can burp on command. I'm pretty good at it. If you do it enough, you start to throw up a little bit, so you can't do it too much. Swallow. It's like a weird, it's like you're trying to suck it down the wrong pipe. I think it's in your stomach. I mean, that's what it is, right? You like close off your lungs and you inhale into your stomach. Burp-nard propulsion systems. Would I rather have bacon, unlimited bacon, but no games? Okay, unlimited bacon, but no games. Unlimited games, but no games. What? Are you having a stroke? Are you genuinely having a stroke right now? But Joe, would you rather have bacon, unlimited bacon, but no games? Or games, unlimited games, but no games? Spencer, are you okay, man? Do you need me to call 911? Commas is pretty much the way I type anyway. Ever use RockSim for simulation? I do not. I use OpenRocket. RockSim seems cool, but OpenRocket is free. All right. second facing operation now. We're getting at the center motor part. And we're taking all these nice and slow. I don't actually know how many passes of this we have to do. It'll be a few, though. We have a lot of material to remove, and a lot of it is unfortunately like not adaptive clearing, which is probably what I should have done. Although we're not plowing into the thing with the full tool diameter, too, so that helps. I think we're at like 35% tool diameter. Outside really quick because I want to know how loud it is outside. I'll be right back. Definitely hear it outside. That's for sure. Let's clear some chips. It sounds fine. It sounds okay. Sounds fine. I just hate it. Nice and clean. That piece of aluminum that's standing. I didn't see that in the Sims. That might be a problem. We'll find out. It's definitely possible that it'll be a problem. Oh, okay. We're pocketing out everything here. Yeah, so we have 4 of these operations to do. Look at the cam simulation and make sure that this is going to actually do what I want it to do. Like, just in case. going to stop the program. Okay. So it's paused. It's paused right now. And then I want to set a point where the program is going to stop. We are going to stop it before the next operation, though. Yeah, we're going to stop it before the next operation because this path is going to be fine, but it might not cut all the way through. I guess we can sort of fly by the seat of our pants here. If it cuts through the bottom, that's great. I just don't have a ton of faith that it will. So if it doesn't cut through the bottom, then I have a program we can run which will cut through the bottom. a lot of material to remove because it's a really lightweight part. I've missed some questions. Yeah, unoptimized toolpath for sure. Let's see if I can get all these. Yes, I do have some... I have some pretty interesting islands, but I looked at the simulation for the cam, and they clean up eventually without being, like, problematic. Yeah, so as someone said, as a hobbyist, like, it's not a huge importance, right? Like, the difference between an operation taking 30 minutes and an hour and a half for me is not a huge deal because a lot of the parts that I'm doing are really just one-off. But if I were doing a production run of like 100 of these, it would make a huge difference. And so I'd stop the operation, go back, and, you know, redo it so that we fix this. Those plunges are disgusting. I love it. What part is this? This is a reaction wheel for Scout. So, this is the wheel itself. We made this earlier. Let me show it here. This is the wheel itself. We made it earlier. It's very pretty. And then this is the housing that's actually going to hold the wheel. It holds the motor, and then the motor holds the wheel. And then this housing protects the wheel from grinding against any cabling inside the vehicle. Why not just use a hand drill? What do you mean? The CNC will cut out the part exactly as I want it, and a hand drill, it would be a lot harder. Any idea which cam system Joe is using? I'm using Fusion 360 for this. Let's see. Yeah, we could stop the program. What I wanted to do is see if I could tell it to stop before a specific operation, and while we could probably do that, I'll just pay attention and stop it before it gets to the point that I want to stop it at. None of these operations are actually going to do anything bad, so far as I can tell, but it's that I might have to add another operation at the end to actually cut the floor off, because I might not go through the stock material on this. Print the Flywheel. I could, but I'm trying to teach myself how to be better at machining, so that's what I'm doing here. Machining it also will be, I believe, a tighter tolerance on keeping the wheel balanced, right? Like, we can take off on the order of a few thou on one side or the other. And so machining it will let us get really precise. Yeah, this is a rolled control wheel. It is not a compressor in any way. Okay, this is now an adaptive operation. And we're going to start to clean up the floor at the end of this. But it's going to take a hot minute. My ramps are probably too slow here. Running the feed at like 75%, so I'm going to turn the feed and RPM up just a little bit, and we'll find out if that's a bad idea. It is a phenomenally unoptimized toolpath. Well, it's going to get milled one way or another, and I guess the way that it's going to get milled is very slowly. This is a 3-flute end mill. Imaginary material, I think. That's very funny. This could not be a worse optimized toolpath. It's going to be a great part. popsicles like 3 or 4 days ago, and they said they were supposed to be here like 2 days ago, and they still aren't. So where are the popsicles? We could have a McMaster pop. Why don't we do that? Oh, my package may be lost. Well, that's a bummer. All right, we're gonna go up to 100% feed rate, I think. None of these moves are that dangerous, so 100% feed rate is gonna be fine. A McMaster pop. Raise your hand if you want a McMaster pop. I think I do. I'm gonna go get one. This is a McMaster pop. You can get them on McMaster. Someone can drop the link in here, but they you get them on McMaster, and they're great. They're actually so I also really like Pedialyte pops. Pedialyte pops are the ones I like the best, but these are way more flavorful. They also do this weird some of the pops have a weird texture to them, but these are really good. And I think they've got electrolytes. Yeah, electrolyte freeze pops. So they're hydrated. the worst toolpath in the history of machining. I almost want to stop it and change it, but the problem is we still need to have that really long tool stick out. So like I just don't want to mess with it, and I'll change the way it's done next time. Sleeve Dog asks, Joey B, where did you find the CAD models for the telemetrum that you used in the Lumineer model? I got that from Charlie Garcia, who had a model of it that was existing. You might be able to find one online, and if not, they're pretty easy to model. I bet if you... I might forget to respond. If you shoot me an email, I should be able to get you a model. They don't ship food to Canada. That sucks. That's a bad idea. They should ship food to Canada. I would order more oh yeah, they don't ship. Okay. I don't understand this toolpath at all. It's clearing out almost the entire middle section. Yeah. The part is very, very lightweight, but the geometry means that like we're milling away 90% of the material that's here. It's almost a circular hole. You'll see eventually there are 4 spars that go into the motor holder, which is in the center. What protocol do you use for the AVA radio? The AVA radio is an XB. So the protocol is whatever proprietary stuff they do there, and then you communicate with the XB over UART or serial. The mic, yeah, Jared says he loves that the mic is attached to an Irwin clamp attached to the laptop. This is actually the controller. This is the controller for the machine. So the laptop is what I'm streaming from, but this is just the clamp is needed because the direction that the clamp for the mic goes, I wouldn't be able to attach it to the screen. It would point up, and I want it to point toward me. So I need the clamp. Step by step, folks. One day this is going to be done. You know, I wish the toolpath is nice. I feel like the cutter is spending too much time engaged with the material, and we should really be like letting it cut air for a little longer. I think that's my only, that's the only thing I'd change. Done with my pop. All right. Joey B, thoughts on I2C? I love it. It's my favorite protocol. I don't have many further thoughts. Include checksums. Saving your chips for a scrapyard or just disposal and recycling? Probably at this quantity, just disposal and recycling. You should blow up all of the chips. I can get them out of there. Geometry, which is cool. Well, we're more than halfway through our program, which is good news because it's been running for an hour and 6 minutes. Let's see. Hopefully that one day is today. I just came back. When I left, you were insisting that the janky vice was going to be fine. Now I want to know what happened. Is this a different part? The janky vice was fine. It totally worked. It was janky because we cut at an angle. However, so far so good. It seems like it's worked out all right. And now we're making the housing for the reaction. So this is the wheel, right? Like this is the actual thing that's going to control the roll axis. We've got these really thin spars on it because we want most of the mass concentrated on the outside of the wheel, not the inside. And this is the housing that sits around this wheel, and then the housing holds the motor so that it protects the wheel from rubbing against the cables that go past it in the inside of the rocket, and it holds the motor. And that's what we're making. All right, I gotta catch up. Whoa. Joey B, I can't take you for a ride, but if you're in California, I can see about doing an F-18 tour in Sim. Whoa! Yeah. If you shoot me an email to joe@bps space, I will. There is no way I turn you down on that. That's very cool. Man, yeah. Need to give the tool the time to focus on its next cut. Absolutely. We're giving the tool a lot of time to focus. We're focusing on the care of the tool today. Yeah, the practice that the tool is doing is paramount to getting a clean part. I'm by no means experienced at all, but this part looks good to me so far. Yeah, the part's good. I'm proud of the part. It's just the way that we're getting there that's a little not so optimized. Yeah, I've been doing this for 4 hours now. Is it just me or is this chat delayed? No, I'm delayed in getting to the chat is what's happening. Thank you, Jared, for the support Joey B thing. You can get new merch. Let's see. Just finished a long day of this, but I guess that's what I'm doing with my evening. Howdy, Nigel. Can we get BPS branded canned air? Yeah, if you get a piece of blue tape and just write BPS on there, that's official. That's how that works. I get a dopamine release every time you do away with the chips. Well, let's do it again. Getting there. Joe, I just got recommended your best video yet. What video is that? I'm a little worried. Okay, sounds good. Thank you for the tour offer. When the Scout F landing fails, we need to have an F in the chat in the comments. Well, let's try to keep it. We'll try to make it successful. That's a really good analogy. This is like mowing a lawn with scissors right now. Can I cool the machine with milk? Absolutely. I have 100% confidence that if we used milk as a coolant, it would work. The problem is that I care a lot about this machine and I don't want to mess it up. What RPM are you running right now? And feed rate while we're at it. Feed rate is like 25 inches per minute, so pretty low, and then RPM 9,400. It's a very weird tool path, and I'm not that proud of it. If I were making multiples of this, we would do it differently. But as it stands, we're more than halfway. We're like 3/4 of the way through the whole tool path, so we're just gonna like let it do its thing. You can start to see the motor housing come into like relief here too. I'll grab a motor so I can show you what will fit in there. But let me also just make sure this looks good. Let me grab a motor. Okay, this is the motor. This bad boy right here. It's like the cheapest little 12-volt DC motor you can get on Amazon. I have a bunch of these, and this is what drove the reaction wheel on Sprint, on the previous Scout Rocket, on Trek. Anything else that's been that scalar that's used a reaction wheel, I've used one of these motors. They're fine. They're not amazing. They're not terrible. So that's what we're using here. And so you can sort of start to see, like, if I clear out I think we're gonna take another cut out of the center, and when we do, you'll be able to like see the profile of the motor in there and how it'll fit. Oh, and then, so you've seen, well, let's let it cut the motor first. Yeah, so you can like see the profile there. So you see the reaction wheel, and so this goes into the motor fits into the hole of the reaction wheel nail here to spin it. It's not actually fitting in right now because what we're going to do is we're going to heat set the wheel onto the motor, so the wheel will get heated up with a blowtorch to like as hot as I can get it without melting, and then we'll place it on the shaft of the motor, and that will set the part onto the motor so that we can drive it. That's the plan, at least. Almost there. Wow, it's so pretty. Alright, I've missed a lot of questions, I think. Why don't we get to that? Oh boy, I've missed a lot. The best video is the milk video, obviously. Yes, of course. Joe, your TikToks are golden except for the one you posted the other day. I do know the one you're talking about. I thought I shouldn't post it. I thought I shouldn't post it, and then I showed it to a friend, and they said I should. So, I don't know what to tell you. Blame my friend who thought I should. I left it in the drafts for a little while. There is another operation with the 1/8 inch end mill, that's correct. That might get us into trouble. I don't know, we'll see. It should be okay. We'll find out. What's your dry mass budget for Scout F? As light as possible. I don't actually have those numbers yet. What platform is the reaction wheel going on? It'll be on Scout F, which is a rocket that I'm building right now. How are you liking the machine? It's a dream, dude. I need to get better at using it because I'm very bad at generating toolpaths, but so far it's nice. You could probably bump that feed rate to 35 inches per minute. If that IP, oh my gosh, I'm having a stroke. If that feed per tooth was correct earlier. Yeah, it was. I just don't, I don't have a lot of confidence into how far we're sticking out the end mill. Joe, what is your favorite song? Musician by Porter Robinson. The motor will go in the middle. That is correct. Let's see. Oh, it's Austin B. Shout out Austin B for real. Who says, I just lost so much money. The B in Austin B stands for broke. I'm sorry, buddy. That's tough. That's a cute motor. Link to the motor. Just search 12-volt DC motor on Amazon. You'll find a bunch. Bless you for pronouncing Shrek correctly. You can start to see what we're doing here, actually. So, you can see where the motor goes, and you can start to see the spars that will connect to the motor. And then what we're going to do is we're going to try to pocket out all of the stuff around the spars. So again, we're removing almost all of the material from this block. When you drank the carbonated milk and said it was terrible, why did you take another sip? Because science is about verifying your results. I knew it tasted terrible, but I had to be sure. I would be worried about damaging the temper of the motor shaft with that much heat. I DGAF about the motor shaft and tampering with it because it's the cheapest motor you can buy. And I don't know, that's actually not a terrible point. But, counterpoint, I'm gonna do it anyway. Do you want to do the opposite of that and get things snug? Freeze the reaction wheel to shrink it, and then let it warm up and press fit itself around the shaft. That is not how things work. When you freeze something, it gets smaller. So you want to heat up so we would heat up the motor shaft. Sorry, we would heat up the reaction wheel and freeze the motor shaft and then put them together. May the guns be with us all. Sorry, I'm really far behind in the chat. We're catching up now. I've always frozen bushings and stuff that need to be press fit, and initially got them go on, then let it warm up, never the other way around, only when smacking something out. Maybe I'll try that then. Maybe I'll try to freeze the motor. Oh! This looks great. We're cutting through. This is actually really good news. It means we don't need to do that other operation. Okay. How do you have the camera tracking the tool? Jared mentioned this, but I'll do it again. The table is the thing that's moving. So you can actually see it shift around inside the machine. The tool is stationary. The tool can go up and down, but the table is the thing that's actually moving. In X and Y, at least. Let's see. Joey B is the first person to spend hundreds of hours on modeling. Rockets are supposed to be quick. Heat makes everything bigger, cold makes everything smaller. How are you doing with the solid? Oh, how are you doing? Yeah, with the solid motor throttling. Doing great. It totally works. I'm really excited about the results. The whole video is filmed and it's a little bit edited. We're waiting on sponsor approval and then it should be up in a few days. Oh my gosh, I'm still so far behind. This toolpath hurts my soul. Hi Joe, I love your videos. Your TikTok scares me a little. I mean, I think that's fair. Are you referencing this, the Speeds and Feeds handbook thing from NYCNC? Yeah, we have something from NYCNC. I can't remember exactly what it is. Covered musician is really good. Thank you. I really am live. This toolpath is worse than I even thought. Yes, it is. Are you going to do any more rocket tutorials like the blip and blop ones? Probably not. I think they're good, but I really hate making them. I don't find it fun. And I want to do, maybe it's selfish, but I want to do things that I have fun doing. Because otherwise I burn out. Could the heat also damage the magnets on the motor? I don't know. That seems sus. I kind of doubt it. Why don't you make your own liquid fuel engine? Because everyone who suggests, why don't you make your own liquid fuel engine, does not understand the complexity of making a liquid fuel engine. It's bleeding. What's the red stuff? The red stuff is... We're going to change the tool in a second. The red stuff is... this. I'm cutting up the fins from Season's Eatings to use them as wasteboard material. Also, let me chop back out some stuff here. So you can sort of see what we got going on now, right? It's coming into view. I just feel like, yeah, I don't even think we have that much of a lip down there, which is great. Man, that's awesome. So the motor isn't going to quite fit in there right now, as I understand it. Not the least of which because of the shaft, but also, shoot, I wish I could make sure that it does fit through. All right, I'm going to do something that's not super cash money. Am I? Maybe not. Maybe I shouldn't. I really want to know if a motor will fit through there. I can always do the heat on that too. I'm not going to do it. So we're going to use the 1/8 inch to clean some stuff up. Insert T3. Okay, so we're going to put in T3. Just the 1/8 inch. We're going to be able to cut through? Yes. Oh boy. What are we cutting with this tool? You know what? Let me double check the cam. Hold on. Gonna kill the tool if we do it because of the stock. All right, we have to mess with the tool length. Oh boy, what a thing! I'm learning a lot today. That is for sure. Okay, that's a different thing. Will I kill the tool that way? Yes. Ah, man. Learning some powerful lessons here, folks. Okay, will I kill the tool at this length? No, I will not. Cool. Commit to the bit. Literally. 'Cause it's like a bit. Nice and tight. Ooh. Wow, I hate this. All right, new length, 3.263. I'm gonna put that in the offsets. Oh no! Oh, okay. We need to go to line 43,987. I hate everything. 43,987. 3263. Someone put 43,987 in the chat. 3263. This is the worst thing that has ever happened. 3263. Okay. That sucks. I hate this part. I will not make this part again this way. All right, what was that number? 43987. Thank you so much. That is actually, it was actually very important that happened. All right. Whew. Boy, oh boy, I do not have a lot of confidence in this right now. Oh my god. This is the worst. This is the worst tool path. This is bad shit. This is the worst. If you asked a question in the last 3 minutes or so, ask it again. The entire thing is not assembled with interference fits. It's only the wheel. The motor's probably going to get glued in there or something. Okay, we're making small cuts. This is basically getting rid of our stock to leave. And doing it in, like, literally the worst way possible. If I were to use Blip as a flight computer, what should I change on the board? Nothing. It's a fine flight computer. Focus on your code. We're making real tiny cuts here, folks. Can I upload bloopers for patrons? Uploading bloopers requires that I edit the bloopers, and maybe one day. The bloopers aren't actually that funny. Like, it's sort of just sad. Yeah, it's less of like ha-ha blooper and more like, wow, he really does not know how to talk. I'm a 24-hour streamer, dude. I'm a real gamer. That's how you know. Icarus Thickerus! See the cuts, they're very small. I am recutting all of these chips, man. Okay. I'm turning off the coolant. There's no point. We're barely cutting anything, so there's no point to the coolant right now. I don't know what's vibrating in there, but something is. And it kind of sounds like the spindle, which I don't like. Oh, I should leave the coolant on and get the water out. So here we're coming into the motor in, again, the most annoying path possible. Could not be worse. Pick a number of 1 and 10. I pick 3. Joe, would you appreciate some feedback on this toolpath in your business email, just from what I see, tips and tricks? So like, feedback is appreciated, but I already know everything. No, that's not true. Actually, feedback is appreciated, so long as you are aware that if you see this and you hate what's happening, you're not alone, because I also hate the way that this looks. Let's see. Is that a relieved shank end mill? No, it's a constant diameter. The dirty coolant looks disgusting. Yes, it does. Can you put a load cell in a rocket to measure thrust? You don't have to. So long as you know the mass of your vehicle, F equals ma. So you can just do F equals ma and you'll be fine. You have your acceleration. You have a good estimate of your mass. That doesn't account for drag, but if you're going pretty slow, you can know your thrust. Yeah, good soup. Is the shank rubbing? Almost certainly. Almost certainly. Oh, Nolan, thank you. I should have said a higher number. Can these machines cut wood? Yeah, absolutely. Know your thrust. I'm saying, dude. Oh, we're out of air. God, this is awful. It's everywhere. I'll just say again, I do wish we had, I wish that on this toolpath, the cutter was engaged just a little less. It's very, I don't even know what to say, man. Annoying. The only reason we're doing all of this with the 1/8" end mill is that I needed to cut the inside of the motor housing, and apart from the motor, it could all be 1/4 inch. Yeah, this tool path is a complete mystery. If you want to know what the machine is doing, I also want to know. Why is there so little coolant? The CNC machines I usually see use flood coolant. So flood coolant is great. It's in terms of cooling, it's definitely more effective than mist. The thing with flood coolant though is it's worse for video, and video is a consideration because I do YouTube stuff, and it is not good. Like it's not great for flood coolant to sit idle for a long time. And with the way that I'm gonna probably be machining those things, with the way that BPS works, the machine is not constantly in work. It's one of those things where this might sit idle for a month or two, and then get used every day for a lot. So it's better to have something that can store well, and flood coolant doesn't do that so much. Personally, I love the retract and slow feed in. It's so dramatic. Get him, Jared! That's great. That's a really good comment. I'm gonna repeat it. I'm on the way to becoming an SLS contractor with these tool paths. That's funny. I just put my hand in there to see. Don't comment about that. I think we're definitely going to leave marks on this piece because of the tool rubbing. I never claimed to be an expert, and I'm glad I didn't. I am the worst machinist in America. Oh, you're done? What do you want now? What do you want from me, bro? Okay. We're back to tool 2. Excellent. The 1/8" end mill lives to see another day. All right. What's the plan here, pal? Oh, I think we're just gonna start cutting out the part, which is great because we've been going for 1 million hours. All right, good luck. Don't crash. Woo! It's happening. All my dreams are coming true. You'll be able to start to see how thin the wall is on this part. Flood coolant is stored in the tanks, Tiff. Where did you get the Tormach? I got it from Tormach. I'm creating a video for them on their channel, and they were generous enough to work with me on, like, getting a machine to me. So it's not like, you know, like it's a deal that I worked out with them. I didn't just buy it outright. You ever talk to my guy Winston Moy? He's the one who taught me cam. I thought for a second you said invented cam. I love Winston Moy. Winston's awesome. He's such a nice person too. I'm still trash at it, but like I usually get parts out sometimes. Man, this sounds like ass. I mean, it'll work, but it's bad. Also, you'll start to see why we didn't clamp this into the vise, because we're cutting through the edge of the part, and as the part gets machined out, it would start to buckle in. And it'll still buckle, but it'll buckle outward now. Isn't it going to... Oh! Here comes the spot drill now. We can get rid of the fog buster there. What was I going to say? Isn't this going to hit the stock now since you're closer to the edge? Yes, it's going to go right through the stock. What is the full... Was that a full frontal chip load? Yes, it is. Can't wait for the reaction wheel video. Yes, it's going to be great. when you checked if it could go deep enough, I think you only checked the inside diameter, not the cut out. That was on the 1/8 inch end mill. On the 1/4 inch, I checked that it would clear the full clamp, and it seemed like it would. And we're all gonna find out together if I did that right. Oh, good night, Daniel. Thanks for joining. All right, now we're doing a quick cheeky chamfer. You know what I think? I think this is chamfering a little bit too much. But it's too late now. Can't put those chips back on. Very pretty. And now I think we're back to tool 2. Tool 2. Here we go, folks. Home stretch. The part's starting to look nice. Got hearing protection? No, it actually is. I mean, the compressor's kind of loud, but the machine itself is not that loud. Do you do any laser cutting? I do not. Let's see. I think you need another BPS intern as your dedicated tool changer. No, tool changing is really easy. It's very fast. Believe that. What else? Magical how time zones work. Is it too much or just shaved weight? Saved weight. Yeah, the goal is to save weight here. I think this part is like 20 or 30 grams or something. Aluminum is great. Yeah, this is the housing for the wheel. The actual wheel has already been machined. I can show it. This is the actual wheel. Right here. And this is going to sit inside the thing that we're milling out. This is so painful to watch as someone with schooling in machining. You know, you win some, you lose some. The last machining stream, I actually feel like I did pretty well, but this is a step back in terms of how optimized the tool path is, for sure. Toe clamps are awful close. They should be fine. They should be fine, I checked. almost there, folks. Oh, we cut through. Happening. Man, we out here recutting every single chip. Where's the line between computer assisted machining and the computer did all the work and I just watched? Well, I think it is done. We did it, y'all. Okay, let's get a little perspective here. First of all, get you to a higher frame rate so that we can get some nice slow-mo of these chips going everywhere. All right. First, spray it out a little bit. And then I'm going to chop back out the rest. Okay, and then real quick, let me get a clip on this camera. I also managed to get away with only one cut. Just one. Which is kind of an improvement, believe it or not. So, let's take this off. there it is. Not bad. And check this out. We milled the backside too, so both sides look really nice. All right. There is crap everywhere. Let me clean this off. Oh man, the shavings are in full force with this part right now. They be out here cutting up my whole hand. So real quick, I don't think we're gonna clean up the whole part, but here it is. Looks pretty great. We need to put 4 holes in those thicker sections right there so that we can get it into the airframe. The back looks nice. The motor, these fingers crossed. The motor fits. Oh, it is a perfect fit. So the motor fits there. This wheel goes on top. We'll cut it out with a Dremel later. The wheel goes on top and it sits flush with the top of this like motor housing. And so the whole assembly like protects the wheel. It's gonna be great. Okay, well, that's good. Also, this looks cool. This looks like the, you know, like the fire brigade symbol? One of those. It kind of looks like that. It's neat. Actually, that's great too, to be able to see when you've cut through the wasteboard, to have a painted piece of wood. This is awesome. It took, I mean, we've been streaming for about 6 hours, so like, depends on how you value your time as to whether that was worth it, but I also think each of those parts could be done with probably like 30 minutes max of milling, and yet we did several hours because of my current skill level. Do I prototype these in printed parts? I actually didn't prototype these. Probably should have. And we'll see if that bites me in the ass. Yeah, I do need to go get dinner. Anyway, this was great. Thanks everyone for joining. Love these chill streams. The next machining one will probably be on the BPS channel, and I'll probably come prepared with better tool paths. We have other parts to make for Scout, and then we just have other parts to make for, have I talked about the meat rocket yet? The meat rocket is going to be the best project this year, hands down. Maybe, I don't know, there's a lot of cool ones, but they all need machining, so we're going to be doing some of that on the BPS channel. Thanks for following, thanks for tuning in, thanks for the advice as well, and I'll talk to you all soon. Bye, folks. How do I end the stream?